Yes, sir.
So I'm sharing my screen. Just confirm. You're able to see, right? 1 minute. So are you able to see?
Yes, sir.
Yes, sir.
Okay. Again, it's gone 1 minute. There is some issue, guys. Yeah. So last class we were discussing about PN junction diode, right? So in a PN junction diode, we saw the concept of depletion layer and a concept of potential barrier, or we also called it as barrier potential, right? We called you had potential barrier. Then we saw the forward characteristic and reverse bias condition of a PN junction diode, and we saw its characteristics also, right? When we saw its characteristic, there is the graph we got. So from the graph, it is clear that we have two types of voltages. One is called as knee voltage. So knee voltage is the point beyond which the semiconductor, that the PN junction diode starts conducting in which condition? In the forward bias condition. So breakdown voltage is the voltage at which the PN junction diode starts conducting in the reverse bias condition, right? And we also know that the forward current is generally in terms of milliampere and reverse current is in terms of microampere. So potential in both the cases is volt only. So based on the characteristic, now we are going to see the application of a PN junction diode, and its main application is to work as a device called as rectifier. Okay. So let's first start with what is a rectifier. So rectifiers are those devices which generally convert alternating current into direct current. See, for example, you can talk about your mobile phone, the charger of your mobile phone. So you have the charger is connected to the mobile phone, but it is not directly connected. It is connected with through a main supply, right? So from the mains, the current goes to the charger, and from the charger, it comes to your mobile, right? So from mains, how much is the voltage that comes actually? It is 230-volt AC accepted. So 230-volt AC is what is going to come from where? From the main supply into the charger. But what will happen is, will this 230-volt from the charger directly going to the mobile? If that happens, right, your mobile can't withstand it because it has a rating, right? Or else you can think of any other device also. For example, you use any other device which works on, let's say, 9-volt battery. You connect an adapter. So generally, when an adapter is connected to the 230-volt AC supply, what happens is, just a minute. When it is connected to the 230-volt AC supply, in the adapter, what will happen is, let's say the device which you are using requires only 9-volt. 9-volt, it requires DC, right? So, but we have 230-volt AC. So, what should be present inside this adapter for first making this 230-volt get 230-volt, which is in the form of AC, to get converted to DC? That device is what is called as a rectifier. Okay, so rectifier is a device which converts alternating current into a fluctuating direct current. Okay, so the process in which alternating voltage or alternating current is converted into direct voltage or direct current is known as rectification, and the device which does this rectification process is called as a rectifier. Okay, so junction diode has the property of offering low resistance and allowing the current to flow through it. In which condition? In the forward bias condition, because we have something called as knee voltage, right? So in the forward bias condition, the PN junction diode will offer less resistance and it is going to allow the current to flow through it. And this particular property of the forward of the PN junction diode in the forward bias condition is utilized for the process of rectification. So based on how much of a wave is being rectified, the rectifiers are basically classified into two types. One is called as a half wave rectifier and the second is called as a full wave rectifier. So before we see what is a half wave rectifier, guys, confirm, are you clear with all these concepts? What a PN junction diode does?
Yes, sir.
Okay. Now we will see what a half wave rectifier does. So rectifier means it should convert an alternating current into a direct current. See, remember, here though I say direct voltage, it doesn't mean it's a constant value. It is going to be a fluctuating value. So as the name suggests, half wave means only half of the input wave is actually rectified. Let's see what the circuit is and how it looks like. Suppose you have a PN junction diode in hand. So this PN junction diode, for rectification process to be carried out, what kind of biasing is needed for it? So rectification property is achieved by the PN junction diode under what condition? Under the forward bias condition, right? So when you connect this PN junction diode across a transformer like this, I'll tell you why a transformer is actually used. So if you use an AC source, 230 volt AC is coming. So the 230 volt directly cannot be fed into the device. So this 230 volt first has to get stepped down. So for it to get stepped down, you need to use a transformer. You need to use a step down transformer, means the number of primary windings should be more than the number of secondary windings. That's what is given here. Right. So number of primary windings should be greater than number of secondary windings for it to be a step down transformer. So the output from the step down transformer is fed into this PN junction diode, and once the wave passes through this PN junction diode, the output is connected at a load resistor. So load resistor means it need not be a resistor always. For the load resistor is the one or is the device which you are actually making use of. For example, in the above examples, it is a mobile phone, or let's talk about any other device which needs 9 volt. Okay, so those devices are what are called as load resistances. Are you guys able to understand? So let's see what exactly happens. A circuit which rectifies half of the AC wave is called as a half wave rectifier. So this figure shows how half wave rectification is actually done. So the AC voltage to be rectified is obtained across the secondary end S1, S2 of the transformer. The P end of the diode is connected to S1. The P end of the diode is connected to S1 of the secondary coil of the transformer, and the N end is connected to the point S2 through a load resistance L. It is connected through a load resistance L. Sorry, RL. Okay. So the rectified output voltage VDC appears across the load resistance RL. So what exactly happens is, see, when you have the wave from the secondary source, I'm using red color, see, when the alternating voltage actually appears at the secondary one, so that is given as an input to the PN junction diode. So during the positive half of the cycle, okay, during positive half of the cycle, S1 will be positive, S2 will be negative. Now tell me, what kind of a biasing is happening here?
Forward bias.
Yes. So it is forward biased. So in this condition, what will happen is that diode will allow the current to flow through it. That is why whatever input you gave for that cycle, that half cycle has actually been appeared. So during the negative half of the cycle, what will happen with respect to alternating current is the polarities will get reversed. Here it will become minus and here it will become plus. Now what kind of a biasing? Now it is reverse biased. So in reverse bias condition, we know that it offers, ideally it offers infinite resistance. So it will not allow the current to flow through. Right. Again, in the next half of the cycle, what will happen? It will become forward biased. So that cycle voltage is going to appear in the output. So this is the voltage across the secondary coil, and this is the voltage that is appearing across the load resistance. So what has actually happened is somebody's mic is on. So what exactly happens is the alternating current is converted into a fluctuating DC. But here, since only half of the cycle, that is only the positive cycle, has got rectified, this kind of a rectification is called as half wave rectification, and this device is called as a half wave rectifier. Am I clear?
Yes, sir.
Okay. So that's the story given here. See, during the positive half of the cycle, S1 will be positive and diode is forward bias, hence it conducts. Therefore, a current flows through the circuit. There is a voltage drop across RL. This gives the output voltage as shown in the figure, this cycle. During the negative half of the cycle AC, S1 will be negative and the diode D will be reverse biased. Hence, the diode does not conduct. No current flows through the circuit and the voltage drop across RL will be 0. Hence, no output voltage is obtained, like how we have shown here. Okay. Thus, corresponding to the alternating input signal, unidirectional pulsating output. Here, pulsating output means fluctuating output. So, it's a fluctuating DC. Pulsating output is obtained. So, this concept is for your information. The ratio of DC power output to the AC power input is generally called as the rectifier efficiency. Efficiency is nothing but the output power by the input power. So, in the case of rectifier, output is a DC power and input is AC power. So DC power by AC power is what is called as rectifier efficiency. Generally, the efficiency of half wave rectifier is approximately found to be 40.6%. So by looking at this number, we can say it is not a very effective one, right? Because its efficiency is less. So for its efficiency to be increased, so why do you think the efficiency is less? Why is it not that efficient? The reason is very simple. If you give 100% input, that is, you are giving 100% alternating current, right? Is it rectifying the whole cycle? Only half cycle is being rectified, right? So since only half cycle is being rectified, its efficiency is that less. So to increase its efficiency, what are we supposed to do? If you are able to rectify the other half also, that is the negative half cycle also, then that kind of a rectifier will have a slightly, I'll not say slightly, it will have a greater efficiency compared to this. Okay. And that device is what is called as a full wave rectifier. Yeah. Can I proceed?
Yes, sir.
Yes, sir.
Now listen, guys. Now let's logically think. For a half wave rectifier, how many diodes are used? Let's answer. So it is
One
only one
diode.
diode. So when you use one diode, it is able to rectify the sense it is able to convert only half cycle of AC to DC. If I want the other half also to get converted, what I can do is we can use two diodes. But the question is, how are you going to connect those two diodes such that you are able to create alternating forward and reverse bias condition for each diode? So that's what is important. Okay. See, again you have a transformer here. Okay. So from this transformer, you're using a step down transformer, right? You're using a step down transformer here. From the transformer, there is an output that is going to appear, right? Now see, let's say this is how the circuit was actually. If at all the circuit was like this, let's see what will happen. So during the positive half of the cycle, out of S1 and S2, which one will be positive? So let's say during the positive half of the cycle, this is positive, this is negative. So what will correspondingly appear across S1 and S2? Out of S1 and S2, which is positive and which is negative?
S1 is positive.
S1 would have been positive, S2 would have been negative. Okay, according to the current diagram that I've drawn, I've used a white color marker, I've erased something, right? Let's see what would have happened if this was positive and this the other part was negative. So what I'm trying to do is I'm trying to do a comparative study. Here I have one diode and one load resistor. The load resistor is very important because the output can be observed only at the load resistor. Now let's think here. So when it is so look at this scenario and tell me what is the kind of biasing the first diode is facing.
Forward.
What
Forward.
is the kind of biasing second one is facing?
Reverse bias.
It is reverse bias because P is connected to negative type. So what I can say is this is a conductor and this will behave like an insulator. Now the question appears, where should I connect my load resistor? See, for example, like the previous case, if I use a load resistor here, if I had used the load resistor here, what would have happened? Will you find any output at this load resistor? In this scenario, when this is positive cycle and this is negative cycle, will you find any output? Think yes, so think and tell me. So this is acting like a conductor. This is acting like an insulator. Then what would have happened? The current which is flowing through this, though it flows through RL, will it be able to complete the circuit?
No, sir.
No, sir.
No,
Reason being, it is encountering an insulator on its path. So it is very clear that I'm not supposed to use my load resistor here. Okay, let's look at the reverse scenario. Let's see what is going to happen in the reverse scenario. During the negative half of the cycle, what would have happened? This will be negative and this will be positive. Right? So the same negative appears here and positive appears here. Now, what about the diode 1?
Reverse bias.
Reverse biased and diode 2 is forward biased. So diode 1 is acting like an insulator and diode 1 is acting like a conductor. Again, if I connect the load resistance here, will this be able to conduct?
No, sir.
Still, you will fail to find the output here. So it is very clear that the load resistor should not be connected the way it was connected in the half wave rectifier. So where are we supposed to connect the load resistor? That is where we come with this idea where the load resistance is used here, which we call it as center tapping method. It's called as center tapping. Okay. So you can actually, instead of following this diagram, this one alone, I would suggest you guys to use it to learn from the textbook. So in the textbook, the load resistance would have been given here. Okay. And this method of using the resistor at the center of the transformer is what is called as center tapping. And the reason why it is done is because, now look at the circuit now. If this is like this, this is S1, S2. If S1 is positive, S2 is negative, then this is forward biased and this is reverse biased. Right? So when it is forward biased, the diode 1 would have conducted. Means the current which is flowing through this diode, it would have gone through the load resistor and it completes the circuit. So it will not go through this branch because this branch is completely like an insulator, becomes an open circuit. Are you guys able to understand? So wherever I say infinite resistance is equal to an open circuit. Open circuit means no current is flowing through it. Similarly, when S1 is negative and S2 is positive, what would have happened? Similarly, when the polarities got reversed, then the diode 2 would have conducted and diode 1 would have acted like an insulator. So if you look at the output, right? Wait. So if you connect an alternating source like this, time Vs, this is VDC and this is time. Okay. So when you give an input voltage like this, during the positive half of the cycle, what would have happened? There would have been rectification taken place. But look at the diagram and tell me, during the forward bias condition, is diode 1 rectifying or diode 2 rectifying? When I say forward bias, S1 is positive, S2 is negative.
Diode 1 is rectifying.
Diode 1 is rectifying. So during the negative half of the cycle, what will happen? The polarities will get reversed. Now, out of D1 and D2, whichever diode is forward bias, that would have contributed to the rectification process. Right? Out of D1 and D2, which is forward bias now?
D2.
D2. Now, what will happen is D2 would have rectified. Again, during the positive half of the cycle, D1 would have rectified. In a sense, now we are able to observe the full wave is rectified. So that is the reason why this kind of a device is called as a full wave rectifier. So for a full wave rectifier, two important points you need to keep in your mind is we need to use two diodes and the resistor should be connected across. The load resistance should be connected using a method called as center tapping. Are you guys able to understand? So this is all about a full wave rectifier. With this, syllabus is over. Okay. So special types of diodes you don't have. Xenodiode and xenodiode application as a voltage stabilizer. All these things are not there. Okay. So one important point is this is either called as fluctuating DC or they call it as pulsating DC or they also call it as a unregulated voltage because it's not regulated, it's fluctuating, it's not stabilized. So clear? Okay. So there are that's all with this chapter. Actually, they have removed the remaining parts. So in special types of diodes, you can just read about these devices: LED, photodiode, not cell, photodiode, and solar cell. Okay, this is a completely theory part. There is nothing for me to explain in this. You can just go through it. What you need to do is you need to read what the device is and you need to study its characteristics. That's it. So this part alone, I'm giving it as self-study. So everything else I've completed. So with this, syllabus is over. Okay. So you guys start studying. I'll share the schedule of when the tests will start and how the assignments will come to you. So start preparing. By the end of this month, there will be tests. There will be continuous tests. So start preparing. If you have any doubt, you can approach me. Okay. So till here, is there any doubt from this chapter? Anything that you have read but you didn't understand?
No, sir.
Okay.
Yes, sir.
Clear? Okay, that's good. So it's completely theory chapter only. Just wait for a minute. Don't leave.
Sir, can you send these notes in the WhatsApp group?
Yeah, I'll do it. I'll do it now. Wait for a minute.